You don't need to know everything, and you can be honest with yourself. When you're somewhere that you're weak at and you can't rely on your hands-on experience, what can the community provide to you?
Serverless architecture design can be really hard. So today I talk with another serverless expert called Sam about how his process looks like for designing serverless architecture. Working at Serverless Guru, Sam really knows his stuff, but is also able to explain it in a really simple and understandable way.
My name's also Sam, so this may get quite confusing as to which Sam's speaking. I'm a serverless developer for Serverless Guru. I've got some global clients. I do a bit of teaching as well on the side for the AWS certifications, and I've been in the serverless space since 2019.
Yeah, there's not many people out there teaching serverless, so that's really cool to have your kind of perspective on that as well. The aim for this video kind of is going to be to just discuss kind of what's your general holistic approach to kind of finding out requirements and then going into serverless design.
Yeah, sure. So when a client comes with some kind of feature request of some kind, right, or an idea that needs to be implemented, right, sort of assuming that we're already sort of working within this serverless ecosystem. In this kind of these architectures, it's very important to understand what services you're integrating with. So when don't just think about your code and where your code's going to run, think about what's triggering your codes. Do you have an event source mapping coming from a queue or an event bridge or a Kinesis stream, a DynamoDB stream? Is this a HTTP API endpoint? So we're going to be invoking synchronously. And the sort of two reasons why that's important, well, there's many reasons, but the two main ones is you then have to think about how your code is going to handle the sort of the incoming Lambda events, and knowing what information you've got, what do you need to pull from elsewhere. Do you need to do some kind of validation on your end? If it's an API, you may want to actually do some event validation before you even start your logic. So those are the sort of things that you would think about. And then what I think is the most important thing is then thinking about what your Lambda does at the end in terms of responding. Doesn't need to respond with something specific. Doesn't need to error. Does the Lambda invocation need to throw an exception, or does it need to succeed even in failure scenarios? So let me give you some examples of that. So the very easy case being an API endpoint. You obviously have a response object you need to return, and it needs to adhere to the API contract. So that's quite simple. If there's some kind of error during your execution, yes, you probably want to throw an exception, and then when that exception is sort of reaches the API gateway, because it's invoking it synchronously, it's going to wait for that response. It's going to find out your Lambda's failed, and then it's probably going to return with some kind of 500, I would assume. Things get a bit more trickier with the other integrations. One that I sort of touched on recently in sort of my own line of work, but also I know had a conversation on LinkedIn with Yang Kui about it recently, is about streams. So DynamoDB streams and Kinesis streams. Now, what I hate about it is when you fail a Lambda execution, the event that caused that failure is sort of thrown back to the start of the stream. And then your next Lambda invocation through this sort of stream invocation is going to do the same event. And let's say that event's got what's called like a poison message in. It's got something that's doomed to fail. That stream is going to try again and again and again to execute that same message and cause a huge backlog behind. And yes, sometimes you may want that behavior, but in my experience, 99% of the time, I want that to fail gracefully and I can move on with the stream because I've got lots of incoming events. So in that scenario, you need to handle the error. So using DynamoDB streams as an example, you have to respond, and there's a certain schema for how you respond, and you can specify which messages have failed and which have succeeded. In which case, you'd probably want to implement some kind of DL queue that you throw the messages in, and this is what I do. And then I make sure that the Lambda will always succeed, so that I know that I'm going to pick up some fresh messages on the next invocation. Think about what happens when things go wrong, because all these integrations, they behave so differently. Those are the first two things. Basically, to summarize your question, think about what's coming into your code that you're going to write. How's the integration behave? What events is it going to provide? And then thinking about the response. Should I be throwing exceptions? Is there something integration specific I need to return with? Or do I respond with like an API response, for example.
That's kind of interesting how your approach is almost kind of similar to like a testing approach, which is here's an input, this is the output I expect, and kind of thinking about that and having that defined and thought about as your first case is kind of, yeah, that's kind of defining the boundaries of the code or of your application, and from there you can kind of start to work your way inwards. That's a really cool idea. I like the fact that you're very actively thinking about exceptions, because yeah, there are so many different kinds of exceptions, and because I don't know why AWS handles different exceptions in different ways in different services. I think that's one of the things, like as you said, like with yourself, you've maybe not used as much EventBridge. If you had a project where you needed to use EventBridge, kind of knowing the services you're going to be using or wanting to be using to at least the level of, I know how to make it work, and if things go wrong, I know how to handle it in those failure scenarios. Like, yeah, there's always the happy path scenarios, and it's like, oh yeah, we've built this application, it's perfect. Users somehow, no matter how many times you've thought about it, users always manage to find a way to do something differently and to end up on a non-happy path. So yeah, thinking about that is really, really important. When you're approaching a new problem, are you trying to find a sub-feature that I know there's a pattern, or I know there's a service that will support that really well? It could be like, I don't know, you've got some sort of delay mechanism and you're like, oh, that delay mechanism could be DynamoDB streams with TTLs if it's not that accurate important, or it could be step functions, or it could be like this or that. Like when you're looking from like a technical perspective, like how do you break it down into kind of the more manageable pieces from a massive architecture?
Yeah, that's a really good question. So the first thing is obviously to rely on previous experience. If you've built something of a particular pattern before, it's very fresh in your mind. You could usually even go and steal snippets of the code and YAML files if you're using SAM or serverless framework. But then sometimes you always need to be doing new things, otherwise we stagnate in our careers. And so how do you learn about all these new patterns? And that is engaging in the community, watching videos, reading articles, and just learning from each other. So that was what I would heavily rely on. And for most scenarios, I'm aware of patterns that I've either used or others have used, either with their successful failures, so I know I can use this, or I should avoid this in a certain scenario. It's tricky. We're relying on managed services, and there's pros and cons. And the pro is we don't need to build anything from scratch really. But the con is that we do have to bend to their wishes. They have certain features and quirks that we need to be aware of. Using like the delay mechanism example you just said, I've actually come across this question on multiple completely unrelated Slack instances that I'm in. And there's a huge amount of debate because there isn't a perfect answer. It depends how long, what is your delay? How much precision do you need? Do you need it to the minute, to the second, or to the day okay? I was very naive. Like the first time I saw this question, someone said, I've got some record and after a period of time I need to do something. And I thought, put it in DynamoDB and use TTL. And after a period of time, that record's going to drop. You catch that in a DynamoDB stream and you then trigger your code. I wasn't aware that has a precision of about, it's either 24 or 48 hours, something along those lines. So it's in the order of magnitude of days. They can't guarantee that your message is actually or your item is going to be dropped from the database. So if you're doing something where you want to expire the item after 30 days, the business says it's okay. If it's occasionally 31, then it's great. If you're doing a session management for a website or like a checkout, a basket, and you want to expire that basket, maybe it's holding inventory that you've then holding from the rest of your website for others to buy, tickets to a concert or something. After 15 minutes, you want to release it back. Can't rely on DynamoDB streams because that ticket could be held for over a day. And then you've got other options. You could use SQS queues have a delayed message processing. The quirk with that is it's got a maximum time limit of 15 minutes. So if your business wants the delay to be within 15 minutes, that's the way you can delay your automation. Now, if you want to be a little bit more, you've got to start getting creative with things. I jokingly said we could chain together multiple SQS queues, and you could compound the 15 minutes. It doesn't really work. It's not a particularly nice architecture. So then you need to start being creative with other methods, having lambdas that crawl your DynamoDBs or glue crawlers. So that's when you need to start being creative for certain problem scenarios. So now, if a question like that was to come up in my day-to-day work, I know of a few options I can use. I know the pros and the cons, and I know the right question to ask. First question I ask is, okay, what is our precision and how long do we need the delay to be? Because that will completely dictate different architectures.
I think one of the points you made right at the start is both using what you have experience or what you have knowledge of, but then making sure that you're constantly learning from both trying out new things yourself. For me personally, I love coming up with silly little nonsense projects that mean absolutely nothing, but mean I get to play with a new service, and just trying to mess around with it, finding out how it works, how it breaks, but then also reading articles from all the different people around. There are so many insanely smart and insanely good developers in the serverless world and in the serverless community that you can find some really valuable things, whether it's finding out, in this very specific situation there's a limitation on event bridge, which I would probably never have discovered until it was in production and all of a sudden my systems are down. But I read this article or I followed this video.
Exactly. Yeah, I think going through a career, you gain, we gain more experience. We become better at our jobs, and it's not because you know the technology better. Because Lambda's 10 years old or something, right? So there are developers that have been developing for 20 years compared to me, and they're a lot better than me. Not because they've had more time at Lambda, because they've only had a few extra years, but it's because they know how and where to solve their problems. They know that they can rely on the documentation for certain things. They know that there are certain people in the network that they can go to that should have most of the bases covered. If a small creator has produced a very good bit of content, it'll probably be echoed and magnified by somebody else. Someone will give them a shout out. So having that group of people on your LinkedIn feed, you tend to come across what's, as you said, good content. I find that's the same as well with keeping up with AWS and all the feature releases that they have. If you try and keep on top of every single feature by following all the feature teams and whatnot, they're producing a lot. They've got hundreds, probably thousands of engineers. But by just following a select few people, if something's relevant to the serverless world, you're going to see it 3 or 4 times on your feed on that day, in which case it's going to be ingrained in your mind and you're aware it's now a feature.
So now I've got some questions that I've had from basically my community asking around kind of serverless architecture. And kind of the first one, the one I got asked quite a few times, is around scalability and how much do you focus on scalability at the start for do you focus on meeting the current requirements, or do you focus on meeting requirements that might develop in the future if the product is successful in 6 months, in a year, in 2 years? How do you balance that kind of equation?
That's a really good question. Someone that works in sort of a contractor role with a client, I would definitely push that question to them and say, what are your expectations? Because there's a cutoff in thinking short term to long term. And the issue is, as we've sort of spoken about previously, we're relying on managed services, and some of them have got soft limits, which is okay, or something you can maybe slightly re-architect. You can start implement a batching mechanism for queues and event-driven architectures. But there's some things that are they're hard limits. If you've got a piece of automation and as the business grows, that is going to result in a longer compute time. If that is eventually going to hit 15 minutes, you've got a problem using Lambda, and you need to think about some of your escape mechanisms. Are you going to split that up into something else? Are you going to migrate to the Fargate? But I wouldn't focus too much on the long term. We build in serverless for many reasons, but one of which is we can iterate really, really fast. We can re-architect fast. We're not, we just focus on the business logic. If you need to re-architect something from Lambda to step functions for some reason, most of that business logic you can copy and paste into wherever it is it's going to run. So I wouldn't be too afraid of migrations and future iterations. I would focus on getting something working that deals with the problem you've got right now. But there are a few things that you want to bear in mind. So I spoke about the Lambda one, 15 minutes, can't get a Lambda that runs any faster. If you're using DynamoDB for your items, and over time, that item may become larger than 400 kilobytes, I want to say, is the maximum size of an item, I believe. Then you're going to run into problems. I've had this problem come up. We decided to then, so our escape mechanism was, let's compress that string, just turn it into a compressed string, so it's a lot smaller, and we can decompress it when we use it. The other option is you could then store that as blob storage in S3 and just have a pointer to your S3 object in DynamoDB instead. And think about what actually changes in your business logic. Only when you retrieve that item, instead of just blindly retrieving that attribute, you instead retrieve that attribute, look at the object, the buckets and the key, and then write some logic to pull something from S3. So there's escape hatches, there's ways of getting out and growing your architecture. And that's kind of my answer. Don't be afraid to make these changes as your product grows and requirements change.
Yeah, I think that point that you made is like focus on now, but don't just ignore what might happen in the future. Consider now like what options you might have. There may be a situation where you're like, oh, actually there are 0 options. Possibly, I don't know, I can't think of a situation like that. But knowing, if it is the 15-minute, could we just move to Fargate? Is step functions an option? Like, you don't have to design that, you don't have to implement that, but knowing that you have 2 or 3 options, as you said, like with your example of the DynamoDB thing, it might be that you, instead of just in your code calling directly to DynamoDB, you might just add a little, preemptively add a little wrapper called get record A. That behind the scenes is just a function that does the Dynamo call, but in the future that can be, that has to get the DynamoDB and then has to uncompress it or has to get it from S3. The core of your code isn't changing, just this one little function, and kind of being able to obfuscate that a little bit in advance, knowing can just help neaten up the code, because it's one place you change one line or change one function instead of having to find every time you've looked for that Dynamo request in your whole repo, which might be 15 times. You've got to change it everywhere. First changing just one file.
Exactly, yeah. Another point, Sam, is some people, they'll be afraid of the vendor lock-in with serverless, and
yeah,
this conversation is had again and again and again. And if you're buying into that serverless ecosystem, you're buying into the vendor lock-in, but it's the forefront of what specifically Amazon and AWS are building. It's always, the keynote is always around something serverless. They're clearly pushing it. It's clearly going away no time soon. So I wouldn't recommend, if you're building a company and you're thinking, we might want to run this on Azure one day, I wouldn't personally focus on trying to make a platform agnostic serverless application. I've tried. It's hard. It's very hard. The cloud providers, they work in different ways, and if you're only going to try and use features that are sort of available across the board, if you want to generalize your event bus, so you're using Event Bridge in AWS and you're using whatever Azure and GCP and whatnot have, you're going to be taking away from the speed at which you can iterate, and it'd be far easier to just, when you need Azure, you've got the business logic, then the bits that touch your integrations, just write something that's custom for Azure there.
I've also had this discussion so many times, and kind of with that multi-cloud serverless approach, kind of you also end up with the lowest common denominator. So especially for like databases, there are some really cool things you can do with DynamoDB that you can't do with Azure's NoSQL database. And if you have to make it agnostic, then it's like, oh yeah, all of those like single table design, like PKSK smartness, if you like the DynamoDB book, all of that, basically 2/3 of it you can throw away because you now can't use it because it's not supported in the other platform, which means kind of you're limiting the power of serverless and kind of missing out on things that could either make your application faster, better, more usable. Serverless is brilliant for getting things built fast.
One of the things that people often complain about with serverless is the cost when you start to scale up. What would your response be to that?
There's always opportunities to cut costs as well running with serverless. There's looking at things that you're constantly retrieving, caching those in the Lambda micro containers. There's using the Lambda power tuning to make sure that you've got the right memory and CPU allocation. There's so many things. Before you even consider the migration, just make sure that you've gone through everything.
Yeah, and even then going to like savings plans. One thing I found out recently is savings plans even apply to Lambda, and it doesn't have to have any level of concurrency. If you're using, say, 1 million gigabyte seconds a month of Lambda, you can get a savings plan for 1 million gigabyte seconds a month, and anything you use over that, that's just charged normally. But yeah, you can save
17%
on your day-to-day bill, just like that. And yeah, like I didn't know that until about a month and a half ago. But yeah, if Lambda is getting a bit pricey because you are using 100 million gigabyte seconds a month, yeah, have a look into that. And there's so many other ways to optimize that just migration isn't the only option. But yeah, so one last question I'm going to go with is understanding bottlenecks. So what can you proactively do to kind of understand and monitor in your application where the bottlenecks are and kind of what needs to get improved?
Yeah, again, really good question. So utilizing metrics and data for sure. Again, we've spoken third time now about the fact that we're using managed services. So there's a lot of things that we're not responsible for, but the data's all there and you can configure all the bells and whistles and fine tune it to be exactly what you need. So again, thinking about what is sort of coming in. So think outside the Lambda again, think about what's triggering it. Are you using some kind of stream and whatnot, or an event bus of some kind? Look at the metrics. You can usually see the age of the message, and if you're starting to see that that's crawling up, then you're clearly starting to create some kind of lag, and you need to crank something up downstream to make sure you're processing these messages faster for sure. So again, it's about understanding your managed services and what options that you have that are available. Also looking at now inside your codes, you want your code to run as fast as it can. If that's becoming the bottleneck, how do you know that? Well, you first utilize X-Ray. It's relatively easy to switch on, and the insights that you get are amazing. If you're making any kind of third-party API calls or whatever, you can see why your Lambda is taking the time that it's taking. And if that is, if we're doing an API request and your API is too fast, that's too slow, that's probably the first place you go, and you find out, okay, why is the Lambda taking so long? If it's making a third-party API call and that's taking 10 seconds, if it's something that is relatively static, that is just doing a GET request, start thinking about whether you can implement a caching mechanism, just not in Elasticache or anywhere, but actually within the Lambda invocations, within the Lambda container. So when that new container is spun up, the first time that the invocation runs, it's going to make the call, populate that cache, and for every subsequent invocation of that container, it can pull that value from a local variable and save yourself potentially 10 seconds. Beyond that, understanding your managed services, what's coming in, are you creating some kind of lag? Look at the metrics that you have available within CloudWatch, create alarms. Don't sort of leave it you can leave it till the end. I think that's being honest. That's what I tend to do. I don't like setting up the alarms. I find it a little bit awkward. But you could proactively think about that at the start. You get all your infrastructure. You have a Lambda that's pretty dumb, not doing much at the moment. Get those alarms in place when the queue has got a backlog of a particular size, if the message age is becoming too large, if the DLQ is starting to build up. Utilize CloudWatch alarms. Get alerted when these things happen. If you're running serverless, usually going to be either microservices or lots of smaller services, and you can't manually stay on top of all of that. So utilize the automation that either AWS are giving. There's a ton of other third parties which probably do a better job, but I find they're hard to integrate into the real world, especially if you work at larger enterprises. That usually involves data leaving the AWS ecosystem normally, and companies, they need to be convinced that that's worth it. Then they'll normally say, no, just use what Amazon or AWS provides.
Yeah, I think pretty much everything you said there is pretty bang on and super useful for first it's the visibility, and then it's kind of how do you deep dive into where your challenges are, and then again it's the knowing your services. I think that's probably the biggest takeaway from this whole talk so far is knowing your services that you're using well can really help make better decisions or plan things better for the future or handle things better when they start going wrong or when they start becoming an issue. So the last thing is I've come up with a fun little architecture kind of design challenge. I'm not expecting you to design the actual architecture, but just kind of talk through what your thoughts are, what jumps out at you. So this is an idea for a product, and the idea is that it's kind of going to be something similar to a Zapier, where you can set up different triggers, and those triggers you can then define kind of what happens. But this is going to be specifically for AI processing of Word documents or PDFs. So you're not building the AI, you're not hosting the AI, you're going to use some API, something like ChatGPT. And kind of the features are that there's a UI, and you can upload a document. It could be a PDF, it could be, in this case, a research paper, and you can give it a little command. It could be something like, write a 500-word summary of the key points of this paper. And that gets processed, and it comes up both in real time, it comes up with the response, but also that response gets saved and the command gets saved so that you can access it later, say some URL. You can then actually ask follow-up questions to that same document, both in the first request, and if you come back 2 days later, or if you send the link to a friend, they can ask the next question. Third, and by the way, if you want to jump in at any point and just say, okay, this is something that jumped out, just go for it. You can create an S3 bucket and attach specific rules to a specific folder. So this is kind of where the Zapier-esque thing happens. So you could say that there's a folder called Summarise, and anytime a file or PDF or a Word document lands in there, send a predefined Summarise command to the AI, and then send a notification to the people that have been attached in the metadata of that file. That means that I'll get an email notification in 30 seconds or a minute saying, hi, here's the response, and here's a link if you want to ask more questions. And kind of the final point is around having a UI where you can look through all the documents that have been processed, and then you can kind of basically jump into an existing document to ask more questions or see the questions and answers that have been provided. With this, you can then filter it based on a couple of different things, whether it's filtering it on whether it's a custom command or if it was a predefined command, who created it, the date it is processed. But you can also do like a free text search. So if you know, there was this research paper, I'm going to check if anyone else in my department has done an analysis on it. You can search for it and find if that paper has been processed.
Let's start with the easiest. So I'm primarily back end. I don't really enjoy front end. So front end should be nice and easy. Typically with these serverless architectures, you're not trying to provide your front end as part of the functions. So we'll try and sort of segregate everything. The typical architecture for the front ends that everyone tends to agree on is one of these rare architectures where there's little debate. It's got a ton of upside and almost no drawbacks. That would be to build using some kind of framework. Let's just say React, for example. Store that in S3, put that behind Cloud Front, and you're then given a serverless, scalable, and globalized front end. So that's fairly easy. You can have users based all over the world. So that's the easy thing. Now, the documents, because of the fact you want to sort of pre-process them and whatnot, that means that we need some kind of backend. So let's think about where we want to store a lot of these things. So the documents, a good place to store those would be in S3. So, and you've already sort of hinted at that in one of the points anyway. Why do we not store it in something like DynamoDB? If we're going serverless, why not use great integrations with Lambda and whatnot? And again, we spoke about it earlier. A file could very likely be larger than 400 kilobytes, in which case we're going to have issues sort of storing that text in a raw form. So storing the objects in S3 is definitely what we should use. You spoke about storing the commands and the responses somewhere so that we can sort of reuse them later. That'd be a great place to store those in DynamoDB. I'm thinking along the lines of some kind of item. PK can be some kind of ID, I don't know, the request ID, I don't know, or a response ID, and you could have a prompt attribute and the response attributes, and those can probably be kept in plain text because it's very unlikely that those are going to be larger than 400 kilobytes. Now, let's talk about the interesting bit now. So we've now got a few services. So we've got S3, which we're using as integration, and we've got DynamoDB, and we obviously want to write in Lambda. So you have a use case where we have particular folders. So we have a folder called Summarise, and we may want to trigger some kind of automation at some point. So we could utilize the S3 event notification feature. So that's usually if you create an object, delete an object, or update an object, it can trigger this automation. Is this a good use case for what we're doing right now? I think so. I haven't read too much into it, but it sounds like it. So from that, you could directly trigger a Lambda function if you wanted to. So now we need to think about, let's think about when things go wrong now, because you could very naively say, yes, okay, let's just trigger my Lambda function. My Lambda function does some kind of work. Maybe there's an endpoint, an end scenario where we're storing some data somewhere, and that could be that. You build it, you ship it, and it's done. But what happens when things go wrong? I believe S3 will trigger asynchronous invocations of Lambda. So I believe that we get a dead letter queue out of the box, I believe. Not 100% on that. To be safe, and I've had to use this integration a lot in the past, I like to do something a little bit different. So rather than our event notification invoking the Lambda function directly, I like to put two things in the middle. So I like to put an SNS topic, and I like to use an SQSQ. So the reason that we have the SQSQ, let's start with, is we can control the rate at which these Lambdas are being called and invocated. If we've got downstream services, it looks like we have maybe the Open AI API as a downstream API that we're calling. If we were to get tens of thousands of documents land in our S3 bucket at the same time, we could very easily throttle our API usage. And so what we can do with the queue is we can set a sort of a rate limit, how many Lambdas can be reading from this queue at any one time. So at that point, we're not just blindly letting as many Lambdas implicate as fast as they can. We control our downstream services, don't throttle any APIs, don't throttle any other services. If we're writing lots to DynamoDB, you can throttle that API as well. So that's why I'd like to put SQS in there. You can then set up a DLQ. So if a particular sort of sequence of events fails, we at least have that stored somewhere so we can look at it later, redrive it if we want. Now I like to put SNS in front of that because that allows us to have a fan out pattern at some point. So when you're using SNS, if we want to trigger a second bit of automation down the line, and thinking back to what we talked about earlier with the short-term versus long-term thinking, this is kind of, it's more or less free. You're just throwing in an SNS topic, it's no big deal, but it allows us in the future to then maybe subscribe something else to this topic. Maybe another queue, do some other automation, it could be any other integration, a step function, a direct lambda function, it doesn't really matter. But we're just going to subscribe our SQS queue, which sort of protects us in the future. So that's a typical pattern that I like to use. And then with the Lambda, we'll do whatever processing it is that we have to do, probably call OpenAI. Aside from that, anything else that sticks out, obviously by having the everything stored in DynamoDB, when we've got these follow-up questions and whatnot, we write our code. Our code can pick the particular item from DynamoDB, and then we've got all the context we need. We have what was called before, we have what the response was, probably some pointer to S3 with the bucket and the key, so we know what the object was, for example, and from that your code should be able to do whatever it is that you need. And I think that's round it off there.
One little extra thing is around like the searching and filtering. Not talking about the front end and how you do that, but kind of there are lots of different ways of adding filtering or searching. What approaches have you found that work for both filtering or for searching using AWS or other services?
I'm gonna be honest, I'm not too sure. I haven't done a lot in this space, so I'm trying, as we spoke about earlier, I'm trying to think about my hands-on experience. I don't have much. So my next thought process would be, okay, what have I read? Funnily enough, I read an article, it was a medium, I didn't read it, I got sort of through the blurb, it was like 7 a.m. this morning. There was an article on exactly this, how you can do free text search in a serverless way, which is very, very niche. It would have been one of my connections on LinkedIn, posted it, I got partway through it, but again, I don't work too much in this space, so it wasn't particularly relevant to me. But because I'm in this community and because I'm sort of just very casually looking at content, just being aware of what's out there, I now know if this was the real world and I had to do this, I now have an article I can go to that pretty much has that, hopefully, a polished, finished architecture solution with the pros and the cons that I can reference. So I hope this is a great example of what we spoke about at the start, that you don't need to know everything, and you can be honest with yourself when you work in different parts of the serverless paradigm, and when you're somewhere that you're weak at and you can't rely on your hands-on experience, what can the community provide to you before you then start going and looking at documentation and whatnot. So that's going to be my answer for this one.
That is an absolutely perfect example of what we talked about earlier. And yeah, it happens all the time. Like it's so regular that something comes up that you kind of know of but don't know about. And yeah, like I was chatting with an AWS recruiter yesterday about like how to become a really hireable serverless or AWS developer, and he said one of the key attributes that most companies are looking for isn't do you know everything, but it's do you know how you can find out something. Like that's what a lot of companies are looking for. This has been super interesting and kind of nice to see that kind of a lot of the things that I was thinking you have similar approaches. If people want to reach out to you, connect with you, how best can they do that?
Yes, primarily on LinkedIn. I think you can find Samuel Lock's my name. I think I have the Serverless Sam handle on there, so you could search for Serverless Sam as well after the trading slash, and you'll probably find me. Beyond that, Serverless Guru have always got openings. I haven't checked recently, but they've got tons in the serverless space, front end and back end. They've got some huge clients and all sorts of work in all sorts of different languages. So have a look at their careers page. Always chat to me if you want to know a little bit more about it. But Advocate, it's a great place to work. They really look after their team, and it's global and a bunch of really, really smart people. I can't stress that enough. I've learned so much. I've been there since February, and we're recording in September. So I've been there 9 months or something, and the amount I've learned from them, not just the client work, is unreal. Thanks for having me on, Sam. I really enjoyed it.
We talked about a lot in this video and there are some amazing takeaways. If you're wanting to continue your learning about serverless architecture, then check out this video here where we look at how we can design a WhatsApp clone and build it completely using serverless.